Okay, now let's look at the multiplicative model. So let's start with setting up some initial values for alpha, beta, gamma, and m is 4. Okay, we start with initial value for trend, and that will be start with the parenthesis. So average of the second year minus average of the first year, and that gives us amount of trend for 2 years. So you divide by m, that will give you trend for one time period. Okay, now initial value for L sub t is the average of the first year, and then we add m minus 1 over 2, because you have to adjust it, times the trend value. Okay, now the initial value for the seasonality is for the first season. You take the average of the first season of year 1 and year 2, divide by 2. Then in the additive model we subtracted the average of 2 years. Now we need to divide. So we'll enclose this with parentheses one more. It's really not needed, but we'll put it again anyway. So average of 2 years, and this should be absolute referenced. So this is the multiplicative factor initial values. Okay. Then we need to set up the rest of the model now. Okay, now the forecast then is L sub t plus t sub t times the previous, okay, so that's the multiplicative model. Okay, in the additive model we added the two. So this is the forecast. And then the error is actual minus that. So now we need to set up the smoothing formulas for these three. Smoothing formulas, okay, right here. Okay, let's move the smoothing formulas down here so we can see them, and we can move them back. So first one will be the previous L plus the previous T plus alpha, you need to absolute reference that, times the error value divided by the seasonality, okay, from the previous cycle of the same season. The trend is, so here we need to be careful, look at the formula, slightly different. Okay, the t value from the previous season plus alpha, absolute reference that, beta, absolute reference that. Alpha times beta times E divided by the smooth seasonal index value from previous time. previous cycle. Seasonality is smoothing for seasonality is previous smoothing. Okay. Plus gamma absolute reference that times E divided by the sum of previous L and T. Okay, now we can copy the whole thing all the way down up to here. Okay, now we have the multiplicative smoothing set up. Now we have to set up the error measures. So let's move the formulas back up here. Okay, now again remember the fitting sample and holdout sample. 68 to 99 is the fitting sample. Okay, so that will be 68 to 99. That's MSE, and in a similar fashion we can find these three. MASE will be the same two ranges, except the base range will be from 67 to 98. We've already gone through this in the previous example, so it's easy enough. So that's the range for MASE, and a similar range for Thiel's U. Okay, for holdout sample it will be what, 2000 to 2006. Again the formula. Okay, so that's MSE, and similar ranges for these three. Similar range for these three. Okay, MAE, MAPE, and RMSE, and MASE would be one whole season shifted up. So here are the ranges, and same range for Thiel. That. So now we can run data solver. Okay, now reset, because we have the previous parameters here, reset it, start fresh. So multiplicative model, we will minimize RMSE. Now this time we'll be minimizing for these three alpha, beta, gammas. Alpha, beta, gamma less than or equal to 1. Solve, and we have the multiplicative model set up. We'll do a comparison just a little bit. So let's first set the models up.